Okay, so I've got a distribution here. So it says describe the shape, center, and spread of the distribution. So there's a total of 56 years from 44 to 2000. So that's a spread of 56. So we're going to say shape, center, and spread. Shape, well, it's mound shaped and it's right skewed. Clearly right skewed because of the direction of the tail. The center, we need to find the median. Well, there's 56 observations, 56 years, and each year is represented by a number for the number of hurricanes that hit that year, right? So this is saying that in 1 year there were 7 hurricanes, in 16 years there were 2 hurricanes, etc. So the median is going to be somewhere between the 27th and the 28th observation. Let's see, what did I have? 56? So there's 56 observations, half of that is 28. So I need to be between the 28th and the 29th observation. So there's 30, 35. So the 28th and the 29th fall in this category of 2. So therefore the median is equal to 2 hurricanes. So shape, mound shaped and right skewed. Center, 2 for the median. And the spread, well, in 5 years there were 0, 1 year there was 7, so the spread is from 7 to 0, so the range is equal to 7. Question 5. It says that we are supposed to make a stem plot, give numerical description of this distribution. Are there any outliers? Write a brief discussion of the shape, center, spread of the angle of deformity among young patients. So I've got a bunch of angles of deformity here. They're supposed to make a stem plot. All right, so what I've done is I've entered all the data into the calculator, and then I'm going to sort that list. So I'm going to go list, ops, sort, and that's in list 4. Now I can go stat, edit, and here are all my stems and leaves, right? So I've got 10s, 20s. Are there any 30s? Just a couple, and a 50 it looks like. So I've got 10s, 20s, 30s, 40s, and 50s. So there's the stems. Now I need to fill in the leaves. So what do I have? 13, 14, 16, 16, 17, 18, 18. Now I go to the 20s. So 20, 20, 20, 21, 21, 21, 21. And then 22, 23, 25, 25, 25, 25, 26, 3 26s, 4 26s, a 28, a 28, a 28. Now I go down to the 30s. So there's 3 30s, 31, a 32, a 32, a 32, 34, 38, 38, 34, 38, 38, and then a 50. Okay, so make a stem plot. Well, there's the stem plot. Give a numeric description of this distribution. Well, it's mound-shaped, right, and it's got a fairly long tail on it, so it's mound-shaped and right skew. So numeric description, again, if it's skewed, we're going to use the 5-number summary. So we'll just go stat, calc, 1 var stats on that list, list 4, and my 5-number summary is 20, 25, 30, 50. 20, 13, 20, 25, 30, and 50. So shape, mound-shaped, right skewed, center, 25, spread, 37, right, because from 50 to 13, so that's 37. And that's it for that. And now, are there any outliers? Well, the 50 looks like it might be. So let's see. From the Q1 to Q3, that's 10. Multiply that by 1.5, we get 15. Add 15 to 30, we get 45. So anything bigger than 45 is an outlier. So the answer is yes, 50 is an outlier. And again, we could have just graphed that, right? We could have just gone to the stat plot and done a box and whisker plot on list 4. And let's turn that second one off. And then go zoom 9. Oh, there's more than one outlier. Whoops, what's happened here? Let's see. Oh, it's from list 1. I need to be on list 4. And zoom 9. There we go. So there's the skew with that long tail, and then there's the outlier. And the last one. You measure the age, marital status, and earned income of 1,463 women. The number and type of variables you have measured is, well, we've got age, marital status. So age, marital status, earned income. So there's 3 different variables that we're measuring. So there are 3 different variables, right? Age, that's quantitative. Marital status, yes or no, or I suppose you could have yes, no, widowed, divorced. So I guess there's some choices there, but that's going to be categorical. And earned income, that's going to be quantitative. So I've got 2 quantitative variables and 1 categorical variable. So what do I have? 3, 1 categorical, 2 quantitative. So the answer to that must be E.